Good afternoon. It's great to have you here. Don Dice and I have done some seagrass work together in Indian River Lagoon over the years. Uh, that's the way I know him, but he's going to talk about the Everglades today, the river of grass. And Don was a consultant for 45 years in environmental science for industry and government. His areas of interest include environmental evaluation, assessment, monitoring of marine, estuarine, and coastal projects, restoration of estuarine and marine ecosystems, impacts of oil and gas exploration, development and transport, disaster response planning, natural resource damage assessment related to disasters, and environmental rules and regulations, which is quite a basket of jobs. He says he retired in August 2023 from Atkins and has been working with Brevard Zoo and others, including me, on seagrass and other restoration projects within Indian River Lagoon. And he's also on the Citizen Oversight Committee for the Save Our Indian River Lagoon and is going to talk today about to us about a not a small project, Everglades restoration, the river grass. It's quite a complicated endeavor. And Don, take it away.
Thanks. I think I can walk you through it. We'll give it a shot. Well, this is the outline for the agenda for the talk, and you will learn acronyms here. I think that every one of the meetings that I started with the Corps of Engineers, when I worked with them, we decided on acronyms for the project first. And so you'll learn, there'll be an introduction and overview. You'll learn about the C and SF system, SERP, IDS, and where are we at with SERP? Then you'll learn about recover and the IGT. We'll go to the SSR, and then we'll look at the salinity target for Florida Bay. And Florida Bay, to me, is what Everglades restoration is all about, getting water down to Florida Bay. And then we'll look at the ongoing challenges of Everglades restoration. So this is the restoration concept right here. And you'll see that the pre-drainage flow was one where the water went down the center of the state to southwest Florida coast and down into Florida Bay. And some of the water did go across transverse glades into the east coast. There was a little bit of a slough that went up to the Loxahatchee River, but there was nothing, and some of the water did go over in the Caloosahatchee River over into the Fort Myers area and out into Pine Island Sound. But that is a very little amount of water that did. Most of the water went down through the center and to the southern part of the system. And that system was changed by a series, by the creation of the Everglades agricultural area, by the water conservation areas. And the whole concept was to get the water off the land. It was a flood control district. And that's what we all knew them by, was the flood control district. And so it was to get the water to the East Coast and to the West Coast and get it off the land, and particularly off from Lake Okeechobee, through the St. Lucie estuary and through the Caloosahatchee River estuary to the west. So the restored flow, we can never get it back to where it was, but we're trying, the whole concept is to move more water to the south and less water to the coast. So that's the whole concept. So pre-alteration, we had these systems here. We had the pond apple swamp. We had swamps in around the western edge and the northwestern edge of Lake Okeechobee. We had the glades down here. We had the Ridge and Slough system. We had Shark River Slough and Taylor Slough coming down into Florida Bay and the west coast, and some of these little creeks and across this this ridge right here leading into Biscayne Bay. So most of the water going into Biscayne Bay was actually through groundwater. And then the whole system has been changed into the Everglades agricultural area up here, these water conservation areas here, 1, 2, and 3, and this is Everglades National Park at the southern end of these systems. I'll particularly focus on along the way on these canals right here, which bisected Water Conservation Area 3A and 3B. So Big Cypress Swamp is over here, but what was created was a channel over to the St. Lucie River into the southern Indian River Lagoon, and creating a heavy water source over into that area, and also a channelization of the Caloosahatchee River, and water flowing, major amounts of water flowing out of Lake Okeechobee in that direction too. And all these canals, the West Palm Beach Canal, all these canals, the Miami Canal, all going to the East Coast. So that's the current system. So the watchwords of Everglades restoration were getting the water right. And that's QQTD. That's quantity, quality, timing, and distribution. I heard that so many times. And the progression of restoration, and this is pretty much every restoration project, is one of getting the physical conditions right. This is the flow, the water level, and then the water chemistry will come along, and this would be the salinity and the cycling of nitrogen and phosphorus. It will get back to like it was generally. And then finally, the ecological habitats and organisms will come along. So first, the Central and South Florida system. That's the C and SF that I mentioned before. This is 1,000+ miles of canals and levees, pump stations, and all designed mainly, I said, for a flood control, but also for water supply and navigation and groundwater and preservation of salt water, trying to keep salt water back. But finally and lastly was considered the preservation of fish and wildlife. And if I can tell you about one thing about Everglades restoration, it's a lot about operating the system. I sat in on so many operations of the system and how we could alter it to work better. And so now they have 7 volumes. They've split the system up into 7 regions. They have 7 volumes that make up the whole system. And then each of the projects that I'll be talking about, they have their own operating manual too. So it's all these operating manuals. It's what triggers these pump stations to come on, when they're supposed to come on, all this other system of how the system works, how this huge conveyance system works. So CERP, that was the next acronym. That's the Comprehensive Everglades Restoration Plan. It's a partnership between the U.S. Army Corps of Engineers and the South Florida Water Management District. It was created in 1998, and the result was what was called the Yellow Book, and that is the plan itself. And it split the Everglades up into 4 regions. They were the Lake Okeechobee northern estuaries, which is Lake Worth Lagoon and the Indian River Lagoon. The greater Everglades, which is the center part of the system, including Everglades National Park, and then the southern estuaries, Biscayne Bay, Manatee Bay, Barnes Sound, Card Sound, Florida Bay, and then going over to the southwest coast and the 10,000 Island area. And most of the focus in the beginning, and we're still kind of in the beginning of it, has been on Kissimmee River, which is done. Restoration of the Kissimmee River is done, and it's been on Lake Okeechobee, getting the timing of releases right into those pop-offs off to the left and right, to east and west. And then the greater Everglades, trying to look at the greater Everglades and how to use the Everglades agricultural area and clean up the water there, get rid of the phosphorus in the water, and then also how to use the water conservation areas, because they're a nightmare. They turn the ridge and slough system into ponds. Next acronym was IDS, and that's the Integrated Delivery Schedule. And you'll never be able to read this, so don't even try. It has across the top years and dollars. And then the different colors are actually different, what they call generations of projects. And truly they're generations. I mean, each of those are going to be a generation to complete. And we're in generation 1 still. So you know, this, I'm retired. So generation 1. And generation 1 is in the green, and so we have the purple is generation 2, and then it goes on down into generation 3 and 4. And we'll talk about those and what's in those. But the very first one, the blue one at the top, is actually non-SERP projects. And those non-SERP projects had to be done before SERP could even start. So I'll talk about those first. So the significant non-SERP projects one was the Herbert Hoover Dike, and it's the dike under Lake Okeechobee, 143 miles long under Lake Okeechobee. And it was starting to fail. And so they had to get in there and they had to strengthen it and reinforce it. And that project is complete. So Lake Okeechobee will not overflow on the southern end like it used to. And then the other was the C-111 canal down in Dade County. It's the southernmost canal system, and it comes off of the L-31 north, and then it runs across and feeds Taylor Slough, which is the easternmost slough going into Florida Bay. And that project actually started in the early 90s as modified waters. And it was trying to get more water down into the system. And I'll talk further about that when I talk about salinities in Florida Bay. And then we're starting to move into SERP projects. And one of the major ones was the bridging of Tamiami Trail. Tamiami Trail was a causeway with a few openings that led into Everglades National Park. So they bridged a portion of it so that they'd have flow into northern Everglades National Park, a free flow system, and that's complete. And then the C-51, this is the West Palm Beach Canal going into Lake Worth Lagoon, and that they put in a water reservoir and a treatment area to hold back water and salinity, and also they were getting a lot of muck into the center part of Lake Worth Lagoon where C-51 comes out. So it was about modulating the water quality and quantity that went into Lake Worth Lagoon. Now we're getting into Generation 1 projects. This is Generation 1 projects, and the first one I want to talk about is the Indian River. It's the Indian River Lagoon South C-44 reservoir, and there's actually going to be a few reservoirs in the area north of the C-44, which is it's the south branch of the St. Lucie River, and that's the channelized branch of the river. So there's going to be a series of reservoirs in there, and those are still under construction. And then the Picayune Strand comes out of Golden Gates right at the curve where I-75 goes from going south to going west towards Fort Lauderdale. So you can picture that Picayune Strand is there, and that was a continuous flow into Fakahatchee Bay, which is part of the northern bays within 10,000 Island area. And that was they've put some plugs into the major canal, and they've stopped flow and allowed water to flow out into the marshes that are all around there. That was a huge development, Golden Gates was, that really never got off the ground. And so there's a lot of roadways in there, and if you look at it on the map, you can certainly find it. And then they also put in a control structure at the end of the canal to control water flow into Fakahatchee Bay. And then the Caloosahatchee River also got a storage basin on the south side of the Caloosahatchee, a major storage basin to modulate flows, to add a storage area and modulate flows down the C-43, which is the Caloosahatchee, leads into It goes out at Fort Myers, inside in Pine Island, behind Sanibel Island. Generation 2 projects. These are kind of in the thought phase, so they're out there still. So Generation 2 is just being thought about. And this is one that I worked on quite a bit. It's Biscayne Bay coastal wetlands, and it kind of fell apart because one of the major sources of water into this area on the western side of Biscayne Bay, down in the south of the Cutler Ridge area, all the way down to Biscayne Bay National Park. This was an area where they wanted to control water flow into Biscayne Bay, into that area, but they were going, one of the major water sources was a huge sewage treatment plant at the south end of Miami. And all of a sudden the concern was for that it was properly tertiary treated to get rid of all the medical, everything that could be in sewage water. And it became a big concern, and so that kind of fell off the map, and it's still being considered because they're looking at water treatment right now. So the South Florida Water Management District has picked it up and is doing the planning on it right now, and the Corps of Engineers is out of the picture for the time being. Then these are two projects that are in the consideration phase, in the planning phase. Two projects that are really important to the central part of the system, and these deal with actually the water the water conservation areas here, and how to use them. So it's right now in the planning phase. And then the next one is the decomp physical model, which is these canals I've mentioned right down here, these canals and water that bisect water conservation 3A. What to do with them? How do we kind of decompose them in order to get free flow of water down into Everglades National Park? And that would be this flow of water. Right now, the major flow goes down in this small area right here and not through the whole system. So it's how to make that right again, as right as possible. This Generation 4, this is like maybe light years away, somewhere out there, and they call it in planning. I think it's in the thought phase. This is the Loxahatchee River watershed, and what it's about is most of the flow of into the Loxahatchee River goes through the South Fork, which is the channelized fork, and it has a control structure on it. So it's to modulate that flow through that southern part of the system over here and create more wetlands over here and get them hydrated so that it feeds the North Fork. And the North Fork is a wild and scenic river. It's declared a wild and scenic river, and it's what they want to focus and get the water right into the North Fork of the system. Others in the planning phase, this is further south in what's still called the Biscayne Bay coastal wetlands. They're called the model lands. And it's those lands that are in and around Turkey Point, the nuclear power plant, and also further to the south. And that's about extending the C-111 canal across US 1 and into these model land areas so that feeds water down and in through and into Manatee Bay and Card Sound and Barnes Sound. And that way it gets them rehydrated, because much of those lands, and they're called the marl glades. I don't know if you see them when you drive down into the Keys. You see them on both sides. Those are the marl glades, and they have this stubby little mangroves and stuff. So this is an area that needs greater freshwater flow. That's what that's all about. So this is my part, where the scientists hang out, and this is Recover, and we were charged through WRDA, which is the funding mechanism for all of this, WRDA 2000, to have to have recover. We called it recover. It's the restoration, coordination, and verification, and it's the science side with modeling and planners and the resource specialists. And we were charged with putting together performance measures for the system and how to measure performance. And we were told right up front that can't be, looks like it's getting better or it's not getting any better. It had to be numbers. It had to be a number system that we could hang our hat on. And there had to be regular assessments. So one of the first things we did, and these are interesting. I love them. They're called conceptual ecological models. They're really thought models, and it's how the system works. And I tell people about them. I don't know if I've told Bob about them or not, but I tell people about them, and I've used them on other projects too because they make you sit down and think about how this system works. And this is the Florida Bay conceptual model. And it starts out with what are the drivers of the system? What are the drivers? What makes the system, where does it, what makes the system work? And what alters the system? These are the system alterations here. And then what are the processes within the system? And what are the attributes? And once we get down to these attributes, these are what we look for performance measures. This is what we look for how to figure out how to measure the system's performance. So what did we use? We used an overall, we started with an overall model of the system. This is a hydrodynamic model of the system. And the first one was the 2x2 model. These are 2 mile by 2 mile grids throughout the system. And the system actually, it's a model of how the system works and how the system flows. So there's water flow and water levels in each one of those grids. And that's what we use to measure the system. They went from there to a flexible model grid that had finer grid sections where we needed them most. And so that's the flexible model grid is what they use now. And I'm going to be talking about the most current review of the system, and these are the system status reports, the SSR. And I'll go over those in a minute, but I'm just going to say that SSR, it was the 2020 SSR, and there'll be another one done in 2025. They're done every 5 years. The 2021 looked at the existing baseline, what the condition of the system is going to be in 2026. Again, these are models of the system. This is the system modeling. What's it going to be in 2032 when we have the Central Everglades planning project in place, and then 2032 when we don't quite have the Central Everglades planning project in place because we're uncertain about the EAA. That's the Everglades agricultural area. And where it's going to go and what's going to happen with it. So it's got that uncertainty in it in the 2032 PACR. So how did we use these? We took the hydrodynamic model and the conditions it produced, and we created ecological models. And most of them were, a lot of them were statistical models. We created statistical models and then use the output from the hydrodynamic model to predict what the water chemistry was going to do, the organisms were going to do, whatever we were modeling. So these are all the performance measures that have been developed or in development through the Recover group. I worked on the northern estuaries a little bit, but I've mainly worked on I ran the southern estuaries, southern coastal systems group. And so the main ones that we produced were salinity patterns, submerged aquatic vegetation, juvenile pink shrimp, and this was the Browder model. This is Joan Browder. She passed away in May of this year, and God, what a lady. And then American crocodile, that's Frank Mazzotti. He's out of the University of Florida. And then juvenile spotted sea trout, that's the Chris Kelbel and Joan Browder created that model, and then algal blooms. It's under development. Yeah. Okay. So this is the 2020 system status report. That's the SSR that I talked about. So this was again in Word of 2000 that we had to do a status report on a regular basis, and it was determined to be every 5 years. And so this I'm going to go through in a minute here. We developed interim goals and targets uh, for the system and how they did against those interim goals and targets. And I just forgot to mention that the other run that we did through the hydrodynamic model was called the natural systems model. And that's how the natural systems worked, supposedly before anything happened here. All the C, S, and F system went into place. And that's what we compared our results against, was the natural system model. So we're going to talk about salinity in Florida Bay. This is my favorite place here, one of my favorite places. Um, and if you look at Florida Bay, and you'll see it's compartmentalized, and it's compartmentalized, truly is compartmentalized. The flow is not really like a regular estuarine flow, because they have these basins, and the basins actually have ridges, and they have deeper parts into those basins, and that's what kind of impedes flow and holds up flow. And this is a map of the system. The water flows through the Taylor Slough and C111 canal down into eastern Florida Bay right here. And so these are fresher. The green is the fresher water conditions, and then these are kind of fresh estuarine waters. And then this is the part of the system where the flow really doesn't happen all that well, and so you get a lot of evaporation. And I'll show that to you in a minute. But this is kind of a transgression through these. Is over in this the transgression. These are the freshwater systems, and then these are the more fresh estuarine waters. And this is the middle part of the system, and these are the areas far out here, and you'll see that they're fairly consistently ocean water. It's Gulf of Mexico water. So there's been times when Florida Bay has been a negative estuary, and that negative estuary is the worst condition for it, because it'll pull in waters from the Gulf of Mexico. And if you know, they mine phosphorus over on the west coast of Florida, and so it pulls phosphorus into a system that's really is a low phosphorus system, so it creates a nutrient soup within Florida Bay, one of the worst conditions we could get. But it also causes very high salinities. These are salinities above 60 over here in these. And we've seen salinity of 70 in Whipray Basin in the center. This is a positive flowing system, and this is really what we want in the system, where you have the freshwater flow into this eastern part, and then it flows towards the Gulf of Mexico. And you also, there is flow through the Keys also. And then this is the more typical condition, where it's just a lagoonal system. And this is where we see very variable conditions, particularly in the central part, right in here. This is the modified waters that I talked about. It started back in about 1993, where everybody said you've got to get more water. We had a seagrass die-off in the late 80s, 87 or so. We had a seagrass die-off. I'll go through that in a minute. And this whole system is seagrass bottoms. And so we had a seagrass die-off, and we said, you got to get more water down in there. So they started trying to get more water down there, and you can see that they succeeded pretty well in the 90s and early 2000s, and then it started to fall apart. And it's been pretty sporadic since then. This is the 2020 IGIT for Madeira Bay, which is one of those ones right up in the center there that is very variable in its salinity and gets very high salinities at time because it doesn't get water through consistently through Taylor Slough. And these are the results of the model runs, each of the model runs. And this is the gray is the natural system model. That's what we're supposed to be achieving is the natural system model. And this shows you that in the summertime, we may impinge a little bit upon the natural system model, but most of the year is not even near it. So, the current modeling shows that we're still not getting enough water down into Florida Bay. So the seagrass die-off was a cascading of the system, and it was a result of that, what I talked about, the phosphorus coming into Florida Bay. But then it was really a very rich seagrass system that got too it liked it too much. It was too nutrient. There's too much nutrients, and it started to die and decompose and caused a it caused a buildup of hydrogen sulfide in the sediment, and then regular hypoxia on the bottom. Hypoxia is low O2, low oxygen. So it basically asphyxiated the system, and you could pull the seagrass right out of the culms, and it was just dying from the roots. This was the cycle. In 1987 was when we had to die off, and then this is the cycle back around 25 years to get back around to where we were. And Bob can explain the center part. He knows more about seagrasses than I do. But anyway, it is a thalassia system, and we got thalassia back into the system eventually. But 25 years. And then we had another seagrass die off in 2015, a minor, a lesser one, but we still had another one. So the system is still on life support. Another thing that we did, Word of 2000 had in it was something about adaptive management. And adaptive management was really a kind of, everybody kind of, I think all restoration scientists knew we were already doing it, but we didn't have a name for it. And so this was the name for it right here, adaptive management. It's basically, don't be frozen by the things that you don't know, because there's always going to be some things that you don't know when you start a project. And so, don't freeze up and say, well, we got to know everything. Get the project started and learn along the way and adjust along the way. And if you build a robust enough plan, you can make these changes, and then you can monitor it along the way. And we had a strong monitoring program in place to do this. So anyway, that's what it's all about. And we actually defined it, and we put it into action, and it's being used in some of the major restoration programs around the country now. And particularly with the Deepwater Horizon oil spill, all of the work done by that has to go through adaptive management. So what are our challenges? And I'll give you examples of each one of these because I've lived this. And so the first one is it's difficult for agencies to reconcile different culture, technical strengths, and missions. And I can remember in particular a meeting that we had with all these were natural resource agencies. We had all the natural resource agencies in the room, and their heads of the bosses, and you could actually see where you would never get anything done because they each had their own mission, and they couldn't resolve that. Other people had missions too, and we should all work together. They just could not get it. And then the next one is it difficult for agencies to collaborate and agree upon a common goal and a set of priorities. It sounds the same, but I'll give an example of that. The Everglades restoration was not supposed to be about any one particular species. It's supposed to be about getting the habitat back together, getting everything back together, and then we'll get everything back, hopefully. But what's held up the rehydration of Shark River Slough down in Everglades National Park is the Cape Sable seaside sparrow. The U.S. Fish and Wildlife Service will not accept the fact that they need to start restoring habitat as the water fills the slough, and the bird will actually come back up to where it used to be. It actually migrated down into the slough because their habitat was available now down in the slough. And so we just really kept saying, restore that habitat, get it ready, and they'll migrate back as the system fills. It's not going to like fill tomorrow. It's going to fill over time. But they could not accept that, and they've held up the rehydration of Shark River Slough for a long, long time. The slow pace and implementation has resulted in SERP not keeping pace with the continued decline of the ecosystem. This reminds me of a book I just finished of the victim was put into a coffin, and they had to save her before she ran out of air. And this is what it reminds me of. We're not going to save this system. It's going to run out of air if we don't keep it moving along. The challenge of using traditional planning processes that treat multiple interrelated projects as if they're separate. This is core mentality to the max. They cannot think outside the box. They cannot get outside of their planning process. They get so involved in the planning process that they can't see the whole picture of where we're going. Challenges of understanding and using adaptive management as a planning framework for dealing with large unanswered questions, both ecological and engineering. And this is a huge problem again with the Corps of Engineers again. They're pedantic. They cannot see that you need to move the project forward even though you don't know everything. And then the last is a challenge of developing dependable ecological models. Sometimes there's just not enough data. And we were lucky with the salinity models because we had a lot of continuous recording meters out in Florida Bay and Biscayne Bay, and they're recording salinity at 15-minute intervals and have been out there for a long, long time. So we had a lot of data in those areas, and we're able to develop that. That's really all I have. Thanks. I hope I kept it moving. I hope I kept it moving along. Everybody was entertained. I'll answer any questions.
Yeah, obviously not a project without challenges. Questions?
Don, I had a place down in Tavernier and ran around Florida Bay and Hells Bay and the 10,000 Islands fishing and all for 35 years down there until I moved up here 4 years ago.
Yeah, that's a little piece of paradise down there.
Oh, yeah. But it seemed to me, because every now and then we get these algae blooms down there in Florida Bay. And I kind of thought that a lot of the seagrass die-off was what came from the algae blooms. So is that correct or not?
Well, they kind of you got to remember that algae gets its nutrients from the water column. Mm-hmm. Seagrass gets its nutrients from the bottom sediment. But it also has epiphytes on it, and so the epiphytes get their nutrients from the water column. So it's kind of a disparate system that once you get that phosphorus into the water, into Florida Bay, phosphorus and nitrogen together in the water, you've got a nutrient soup in the water column. So what is it going to feed? It's going to feed the algae. It's going to feed the chlorophyll. It's going to feed phytoplankton, and then also the epiphytes. And those are things that seagrass don't want because The phytoplankton takes away the water clarity and doesn't allow light to get to the bottom. And the epiphytes get so heavy on the blades of the seagrasses that they die.
Yeah, that's what most of the people down there used to say. It doesn't get enough light with the algae blooms, and therefore it's dying off.
Yeah, the seagrass die
but
off.
Most of it seemed to be in the northern part of the bay there, from what I can remember.
Right, northern and western
Yes.
part of the bay. That's where that 1987 die-off occurred. Was the northern where it got really hypersaline, and then also the western part that got the phosphorus into the system.
Yeah, 10,000 islands never got touched with it. It didn't seem like.
What was that?
Say the 10,000 islands didn't seem to be affected.
It gets very good flushing.
Yes.
That's what it's saved by is the flushing. Thank you.
I was looking at your list of all of the little projects going in there, and it's very political. I've done some work down there, and I recognize some of that work. My question is, were you able to identify indicator species and get them studied, or did you have to go with what was being studied and then use them and try to fit them all together?
Yeah, we had to go with what was being studied. Yeah, Joan Browder was working on pink shrimp. She was working on pink shrimp within the system, which was a major. And then Chris Kelbel was working on juvenile spotted sea trout. So we had to go with what we, yeah. Well, and as much data as we had. Exactly. We had to pick up what we could.
I wonder if everyone here understands about the seaside sparrow controversy and why that was so important. You did mention it, but I don't know if people know the background, and perhaps you could give us a little context for why that was a stopping point.
Well, the Cape Staple seaside sparrow is an endangered species. Yeah, and so it was significant in the system. There's other seaside sparrows, but the Cape Sable is the one that lives in the Everglades system. So, there's grasshopper sparrow and a lot of different other sparrows that are found within coastal areas. But this one in particular is the one that's down in the Everglades system. And like I said, it occupied the areas that were adjacent to Shark River Slough. And as Shark River Slough dried down, they migrated down into those systems because they use a grassy kind of habitat for their where they live, and it just generated itself in these edges of the drying Shark River Slough, and they moved down into those. And like I said, all you had to do was manage that habitat further up, which was becoming shrubby. But it needed to be burned, and it needed to be managed, and they were just not willing to do that. They were not willing to manage that habitat as it moved further up, and to get it to the right place.
Are there any economic or political forces that oppose or resist your programs? Be brave. Be brave.
I think the main thing that we see, well, WRDA 2000 and subsequent WRDA funding programs have kept some amount of funding going, but that's the main thing is keeping funding going for the project, and that has been what probably has kept it at a slow pace because they're not, the funding is not coming in mass to do these projects. That's why they have to be spread over the amount of time. But the other thing is I've got to tell you that the Corps of Engineers wastes a lot of time in planning. If they would truncate their planning process and get things moving, I think it would, you know, it help them to move along.
Thank you so much for your presentation today.
Sure, sure.
I I've only lived in Florida about 35 years, but I really have an appreciation for what you're doing. In Boca Raton, there was an area where that attracted a lot of manatee, and the leaders in Boca Raton at that time did not appreciate what they were planning, and they planned to put in a boat dock with fuel pumps. And the only thing that saved us from having that happen was because a professor at FAU discovered that there was Johnson seagrass in the area. And I'm just wondering if the work you're doing, does that touch on like protecting Johnson seagrass and that type of thing?
Interesting enough, I could talk about Johnson seagrass because Johnson seagrass is a really unique little seagrass species. It's only, you know, I mean, the blades of it are about this tall. It's very, very small species, and it's one of the holophilas. There's actually three. Well, now there's four probably, but three holophilas in the South Florida area. It's Holophila decipiens, Holophila engelmanni, and then Holophila johnsonii. Well, Johnson seagrass, it's just been came out 2000. Yeah, that the work has been done on it, and it doesn't sexually reproduce. It doesn't have it. It's a what am I trying to think of? I don't know. It's all the same genetic makeup. It's a clone. That's what I was looking at. It's a clone throughout the system, and so it's dropped off the endangered species list. It's no longer an endangered species, and it really I think we thought that kind of all along, but you know we found the male flower, but never a productive female flower, and so that was the problem, and so it finally happened.
So it was recent genetic work that looked at this Johnson seagrass, Holophila johnsonii and Holophila ovalis, that's more Indo-Pacific and Australian, and has been synonymized. So it says that Holophila johnsonii wasn't really a true distinct species, but I don't think it's been officially declassified by NOAA that it's declared it a.
I'd have to look into that. Okay, but it has been the whole ovalis complex is interesting because there's ovalis hawaiiana, there's ovalis these small populations of this ovalis throughout throughout the Pacific and also down into Australia, and so it's an interesting complex, the ovalis complex. Yeah.
I noticed that on one of your models you had sea level rise as a nice little tiny arrow over at the side. And I was wondering what sort of an effect that was having on this whole system.
You're going to make me talk about climate, aren't you? And yeah. Yeah. My wife doesn't want me to talk about climate. And climate. Yeah, there's actually South Florida Water Management, his district had some really great climatologists on their staff. And we learned so much about climate and so much that we didn't realize, you know, about major climate cycles. And I hate to talk about sea level rise or climate change without talking first about climate cycles. And, you know, right now we're in a wet cycle. We're getting major rainfall, we're getting hurricanes. In 2030, we're gonna start to enter a dry cycle where we won't get any hurricanes. And we faced this when we looked at our modeling. We were using to verify our models data from back in the 70s. And we looked at it, and that was a dry period. If you know, between um, 1970 and 2000, we got very few hurricanes in Florida. Very few hurricanes. I mean, you could count them on your hand. And it was also dry. We got wildfires, and if you remember, burns and everything. So it's very hard to talk about sea level rise and climate change in the mix in this because of that, because of the changes in climate itself. We do have models that look at sea level rise and the, taking and looking at how it's going to enter Everglades National Park and go over the ridges and things like that. So we do have that kind, but how much how much that is fact, is still speculation. I know it's not. I know it's not. It's going to happen, but putting into context, yeah, it is. But putting into the context of climate is what we had problems with, because climate mixes in there, climate cycles.
Okay. Don, I noticed you mentioned in there that in the agricultural zone, the reservoir that was, as I understood, that was one of the major parts of the restoration to be used for cleaning the water out of the lake to send it south.
Phosphorus out of the system. Yeah.
And I guess that's up in the air because of the sugar companies aren't real happy about it.
I don't really think that's it. It's just I think it's building them and getting them to work. I think it's more of that.
I thought they'd already started that one.
And the sugar companies, the sugar industry is it's mainly vegetable crops.
Mm.
Yeah, and so it's just all the nutrients coming off of the decomposition of the soils south of Lake Okeechobee.
Mm-hmm.
Yeah.
Any other questions? Anne?
I recently read a book by Cynthia Barnett entitled Mirage. She was dealing with the water situation in the state of Florida. All the people that are wanting it, requesting it beyond the availability of it to be given out. And as I drove recently down the turnpike, and I saw huge areas of land scraped flat in these communities that are put in, like cookie cutter stuff. I wonder, isn't that a bigger problem if we can solve that than we can on the plants? And how optimistic are you that you're going to be able to go forward at a good pace?
You saw the problems, the ongoing challenges, and I think those are realistic. The challenges of we will always, I mean, the rapid growth and the people understanding the importance of fresh water and it's just always going to be a problem. I mean, we face it with Indian River Lagoon, the restoration of that in Brevard County. People, they don't want to pay for it, and it's tough all the way around. No, it is. People want it all and don't want to pay the price.
Isn't the assumption if you restore the water flow, the hydrology, and the water quality, then the other biological systems will come back?
Well, that's what I showed. That's the principle behind restoration. Yes. Yeah.
I'd like to add something. Well, maybe this is depressing to even think about, but you have hinted at it throughout your presentation. I'm speaking to this subject from a political science point of view as opposed to an ecological one or a scientific one. And I think that, what's fascinating is looking at this from a scientific point of view, it's very clear what has to be done. at least in broad terms. Now, whether or not you're going to get agreement by various agencies that feed into this is a very open question. But I think that whole books have been written on the internecine warfare between an entity like the Corps of Engineers, which is highly politicized and has been accused of being a rogue agency or being a supra-state entity. And people talk about, well, the states ought to rein in on what the Army Corps of Engineers does and so forth and so on. Unfortunately, all of that affects your work. And, in a sense, it almost seems like, from your what you have to do, it's almost like nobody is in charge, or you have to wait out what the bureaucrats are going to allow you to do. So, it's kind of sobering for me to see the charts that you've put out there, because it's a really good example of what happens when you don't have political will behind what you do that's very clear and forthright.
No, thanks. That's frustrating.
Any other questions? Uh, uh, Thank you, Don. I think appreciate your presentation, and I think everybody really enjoyed it. Thank you.
Bob does have a copy of it if anybody wants a copy of it. There was a lot of writing on it, and I tried not to just read it.